Okay, we are pretty aware that not every single system of equations is solvable. And I want to look at what you get as far as MATLAB output when something either doesn't have a unique solution or has no solution. Okay, so I'm going to use two problems from your problem set to demonstrate this. I'm going to look at number 1 and number 4. If I build the augmented matrix that goes with number 1, my first row is going to be negative 26, negative 32, negative 3, 20. My second row would be 40, 42, 1, 56. And then the last row is negative 15, negative 17, negative 1, and negative 6. So there's my augmented matrix. You can check this against the one that you create. And if I perform Gauss-Jordan on that matrix, I get this, which doesn't do what it typically does. You're going to notice that the bottom row here is all zeros, and that this third column is not the typical 0, 0, 1 that you expect from Gauss-Jordan. Now, later we're going to look at how do you unpack this into a couple of parametric equations, but the bottom row indicates something that's important. It's telling you that if you have 0, it's equal to 0. That means that there is not a unique solution here. So in this case, you could write out infinitely many solutions. Now, we'll get into how do you sharpen the pencil a little bit and identify how to find those infinitely many solutions, but for right now, we can leave it there. Now let's look at a case where there's no solution. So I'm going to create a matrix B and let this be the augmented matrix for problem number 4. And I'm going to get negative 47, 47, negative 17, negative 321. Second row is 16, 16, negative 27, and it's 452. Third row is 14, 14, 17, 43. Close that, and there's your augmented matrix that represents the system of equations. Perform Gauss-Jordan on matrix B, and hold on, something's not right there. Okay, I just took a minute and looked back to the problem, and I see where my glitch is, I think. If I go back to the entry for B, this should be a negative 47. There we go, and let's try to RREF that. There we go. Okay. Much more expected what's going on here. The problem here is this last row. If you look at this last row, essentially what's going on here is we're making all of the values, x, or all of the coefficients, 0, 0, and 0, and we're ending up with 1. Another way of looking at this is you're saying that 0 is equal to 1. If you get a matrix that indicates that 0 is equal to 1, like it does here, this means that you have no solution. So let's look at the difference in these answers. The Gauss-Jordan for A gave me a row with all zeros and a noisy column. That's what I would call infinitely many solutions. The Gauss-Jordan for B gave me a row where I had 0 equaling to 1. And that's the one I would label as no solution. All right, so go try the problems. If you have questions, drop me an email, stop in the drop-in, and that should be it. All right, thank you.